CubeSats, UAV, stratospheric platforms, and so on, that are grouped in a whole, making a kind of ecosystem that is integrated with the ecosystem of the terrestrial network. And then the network intelligence in the space should establish the best path, the best route in order to communicate in the different parts of the Earth, also very far, and also not well covered by terrestrial infrastructures. By the way, the Space Network Intelligence should establish the routes and manage the resources related to that routes. So, what is the role of softwarization in virtualization in Space 2.0 vision? Clearly, the softwarization means soft things, and then for flexibility, programmability, adaptive reconfiguration capabilities, and so on. Softwarization concerns both the physical layer, and the physical layer softwarization is implemented by means the software-defined radio, or SDR, and the higher network layers. And the softwarization of the higher network layers is managed by the software-defined networking, or SDN. SDR is paving the road to reprogrammable payloads. This is really a big point, because if you launch, for instance, geostationary satellite, the geostationary satellite cannot change. It's launched 40,000 kilometers far from the Earth, and it stays there, untouchable, not changeable. The terrestrial network can be upgraded. The satellite cannot be upgraded. And this is one of the best arguments against the satellite. The satellite is not flexible. SDR could provide the payload flexibility. SDN, the software-defined networking, should allow to manage or orchestrate, this is the correct term, the orchestrator, it's called the software-defined network manager, to orchestrate the transparent integration of our space network with terrestrial network layers, dynamically setting up the optimal route for the information flows, and the resources associated to each route. But concretely, what are these two tools? Let's start with the software-defined radio, the first cornerstone. The software-defined radio has been defined in a lot of ways, but I think that the best definition is this one. This definition has been taken by the book of Andrew Wiglinski, Digital Communication System Engineering with Software-Defined Radio. This book is very good also for a didactic application of software radio. So essentially, the software radio is a tool that allows to implement via software some functionalities that in all the radios were implemented by hardware. In particular, the baseband. Software radios is very suitable for the baseband signal processing, modulation, error correction, coding, error correction, coding, demodulation, synchronization, and so on. SDR should also possess some level of software control over the radio frequency front-end operation. So the software radio really implements the baseband signal processing level of a communication system and controls the radio frequency level that is hardware implemented. The typical configuration of software radio that you know is the open source configuration with the laptop. The laptop processes the information stream in the baseband, with source coding, channel coding, modulation, and then this is the part pertinent to the laptop, framed in blue, and the other part, framed in red, is in charge to an external device, a board, like the famous USRP boards now supplied by National Instruments. Substantially, the software radio implements this part in the laptop and controls this section. Indeed, the board is connected to the laptop, for instance, via USB 2.0 or 3.0 or gigabit Ethernet. What is it, the software-defined network? The definition of software-defined networks or networking has been provided by the Open Networking Foundation, ONF, that is the international forum that provides software, standardization, every kind of tools about SDN. It's an open community. You can access to documents and everything. In the SDN architecture, the control plane and the data plane of the network are decoupled. So the network intelligence state are locally centralized, and the underlying network infrastructure is abstracted from the application. This is a true revolution, because in the traditional approach, each network node, a network node may be a laptop, a smartphone, a server, everyone has its own control plane. So, each network node is characterized by the control plane, data plane, together managed inside the same device. In the SDN approach, the control plane is extracted by the network node and centralized into a network controller. This approach substantially destructures and restructures the ISO-OSI stack, because the control plane becomes something that is on the top of the devices, on the top of the nodes, and it's outside the nodes, and therefore it can be configured in order to manage a given network configuration. If we want to change the configuration, we change the control plane in the server, in the network controller. And of course, the control plane can be dynamically updated as a function of the network condition. For instance, if I decide to schedule different information flows with different priorities depending on the traffic status, this is quite hard with the traditional approach. It becomes very easy and very effective with the SDN approach. Another tool of the softwarization that is connected to the SDN is the wireless network virtualization. In the wireless network virtualization, the network infrastructure is decoupled from the service that it provides. So in the SDN, we decouple control plane from data plane. In the network virtualization, we decouple the network from the infrastructure from the service. So substantially, the infrastructure is becoming something of virtual and shared. In the previous seminar, I received a comment saying that is it possible to perform the resource sharing at infrastructure level? The answer is yes. By the way, the operators are not very favorable, but this trend might be very, very effective because the network infrastructure becomes something that is virtually shared in slices, and therefore it can be used exploited by the services, taking one or more slice of these virtual resources. In order to implement this kind of framework, we should consider 4 components. The first component is the radio spectrum resource that should be shared, and then we have the wireless network infrastructure, that is the second component, bandwidth, hardware, and software, by the way. The third component is the wireless virtual resource that substantially put in the cloud, in a cloud server, a slice of spectrum or of infrastructure, but in order to manage all these the slicing operation, the virtualization, we need a wireless virtualization controller that may coincide with the SDN controller, may be the same. So, if we have these 4 components that are working together, we can think to virtualize the network resources, assigning them to different services, and the slices of the virtual slices are available in the cloud.